Okay, welcome to the study hall for October 17th, 2013. Today's topic is the CE trap in data sufficiency. If you don't know what that is, you will very soon find out. So, just got done covering the forum rules. Welcome. And just to reiterate, when we talk about give me a smiley face, that refers to the smiley faces that are here underneath your name to the left. And when we say multiple choice questions, please give us an answer, we're referring to these answers that are here. Finally, the obligatory warning. It's not really a warning. It's a copyright notice. Is all of the practice GMAT problems that follow are from the GMAT prep software, which is copyright GMAC, unless otherwise noted. There's a couple of them from our own software, but most of them are from the GMAT prep, which is free for distribution, and therefore we can use it here on the study hall and on the forum. Remember that official guide problems, by contrast, are not free. They are paid material from GMAC, and so we cannot use those. The GMAT prep is, not only can we use those, but those are actually the main source of discussion problems on this forum and on the study hall. Okay, so we are going to start here with some problems. Remember, when a multiple choice question is posted, please answer with one of these responses. Okay, let's do it. How about this problem right here? So here's a timer. By the way, this is one of the problems that is not from the GMAT prep software. This is ours. Here's a little bit of time. Give it a shot. This is a data sufficiency problem. All the problems today are data sufficiency, by the way. So it is assumed that you know what the choices A, B, C, D, E mean. So if anybody doesn't know what those mean, you can say so in the text box, and then I'll type what the answer choices are on the screen, or if you just don't remember or whatever. But we do assume that you know the basics of data sufficiency here. So like if you don't actually know what sufficient and insufficient mean, and you don't know what choices A, B, C, D, E are, this might be tough going. But if you need me to write those on the board, then tell me, and I can do that. All right, here you go. I'm going to come on board for an announcement of fun right now. There are currently 8 people with answers, and actually all 8 of you are incorrect. So go ahead and keep working. Oh, yeah. One person is asking what the multiple choice answers are, so I'm going to go ahead and just type those on the board real quick. But all right, there you go. Okay, there's your data sufficiency answers. I mean, those are always the same for all data sufficiency problems. So if you are unfamiliar with those, then you'll absorb a bunch of familiarity with that as you go through. Okay, here are what's interesting about this is that the title of this session today must have not made as strong an impression on the group as I would think that it would have. Because here are your responses as a class. So we've got more responses of C than anything else. By the way, if you are one of the Nesuno crowd here, that's the people who didn't pick anything. make sure that you don't do that. A couple of those are people who just logged in right now, but if you're not picking an answer to these problems, then you're not really preparing for the test that you actually have to take. Because the GMAT is a test where you actually have to answer all the problems, and you cannot move on until you do answer the problem. So just keep that in mind. But the most popular answer here is C, even though the title of today's session is Problems Where C is a Trap. So, I mean, this will become abundantly clear as this session proceeds, but just make sure you know what's up with today's session. In general, choice C is not going to be the answer to these problems, ladies and gentlemen. Okay, let's talk about it. So here's the problem. What is the x-intercept of the non-horizontal line? So first, let's just go ahead and look at a solution of this problem the way that we would with any other problem. And then once we see what happens in the problem, we can discuss this infamous type of trap that exists in the problem. Okay, I'm going to go ahead and kill these answer options. Just go ahead and note what they are, but I'm going to take them off the board so that we have more room to put things on the board. So if you don't remember these, please take them down or go ahead and open up any GMAT book that has problems in it. Okay, there they go. Poof, gone. All right, let's talk about it. The other piece of gold nugget wisdom that you want here is that there are basically two families of approaches to data sufficiency. And this is not just on a problem like this one. This is pretty much across the board. There are, in general, two main families of approaches to solving the problems, where one of those is your textbook type stuff, which includes algebra or other types of theory, and like anything that would be anything that you would call a traditional type of solution, textbook stuff. But then if that kind of thing doesn't work, then you're pretty much left with one other type of approach, which is making lists of cases and testing them. We're going to see both approaches to this problem. Making lists of cases, specific cases, and testing them. There's an upside here and there's a downside here. The upside is that you should never really be at a loss for how to approach these problems, because there's pretty much two things you can do. I mean, if you try an algebraic approach to a problem and it doesn't work, then it's pretty much time to start making lists. And if you try making lists and that doesn't work, then it's pretty much time to look for a textbook type solution. I mean, the downside is that there are not nearly as many cool ways to solve these problems as there are with multiple choice. With multiple choice, you have all these cool things you can do. You can back solve, you can plug in your own values, you can estimate, you can sometimes use plain old common sense. There's so many things you can do, it's kind of neat. Whereas on data sufficiency, there's kind of just two. So downside is there's not as many cool things, there's not as many tricks in your hat. The upside is that you should kind of always know what to do. Because if one of these two things falls flat, it doesn't work, then just do the other one. So let's look at both for this problem, especially for statement 1. So you want to know what the x-intercept is. Like, also make sure that before you start solving these problems, make sure you define what the goal of the problem is in the first place. So for any data sufficiency problem, all of them, define exactly what the goal is. first. In other words, don't leave it in terms of like abstract concepts like sufficient and not sufficient. Make sure that you know exactly what those mean in terms of the problem at hand. So in terms of the problem here, let's move this down a little bit so that we can write that stuff. The question is, what is the x-intercept of this line? So just to give you an example of what I mean by defining what the goal is, I mean, this may seem trivial to you, but it's actually the biggest issue for most people even after months of studying this stuff. Not sufficient means, in this problem, you can find what? And sufficient means you can find what? Chat box, go ahead and tell me. Yeah, you can find different values of x. Now, in particular, yeah, you can find two different x-intercepts or more, but as soon as you find two, of course, you're done and you prove that it's not sufficient. So two different x-intercepts or more. But as soon as you've got two, or as soon as you know there are two, that's the point. Let me tell you where I'm going with this in particular. Where I'm going with this is that you don't want to say, I don't know. I mean, on one sense, I don't know the x-intercept is the same as, there are two or more x-intercepts. But this is actually a goal that you can try to achieve, whereas I don't know is not a goal. Like, this is something that can actually drive the problem. This is a motivator. This is like something I can try to find. As opposed to, oh, I don't know, la 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 la, which is not really a goal. So don't express this as I don't know it. Because that's just, it's not actionable. And I mean, when people have trouble with data efficiency, the trouble usually stems from the idea that they don't have goals. That they're just sort of wandering around the problem without a purpose. And a big part of it is that you define these things in a way that is actionable. So two different x-intercepts. And then sufficient means that you can't, sufficient means you're stuck with one, right? So means you're stuck with one. Okay. Make sure that you get that on the table before you do anything. Because as dumb as this sounds, even when people have been studying for this thing for months, the biggest issue is still that they are not defining a goal and working towards it. Kind of not really working towards anything. Okay, so let's do statement 1. And then we can do statement 2 later. Okay, statement 1. Let's take a look at algebra. Statement 1. How do you, okay, what is the x-intercept of a non-horizontal line? So when we talk about theory with coordinate geometry type stuff, we're generally referring to one of two things, which means either your algebra type approach or just trying to visualize. And you can mix and match those. I mean, if you take an algebra approach to statement 1, it doesn't mean you have to take one to statement 2. So for coordinate geometry, theory means either algebra, like the whole y equals mx plus b thing, or visualization. You should be equally able to do both. One thing that I notice with forum users a lot is that they are very, very good at algebra, and they neglect visualization. Like a lot of users on the forum do not ever think about what things look like in coordinate systems, which, that's just as important, and there are a lot of problems where you have to think about it, so just be prepared for that. In statement 1, though, it's going to be algebra, because if you think about what this statement means, I mean, you can't readily visualize a comparison between a y-intercept and a slope. I mean, those are not visually comparable things, because this is a coordinate where the thing crosses the y-axis, and this is the slope, which is not a coordinate. So, I mean, this is kind of like saying Ron's weight in pounds is equal to his height in centimeters. I mean, that may be true, but that's not really a thing that you can visualize, because one of them is a weight and one of them is a height. So as a result, this is going to be pretty much an algebra thing. So let's look at it. How do you write statement 1? Text box. Yeah, Yannick is getting there, although y-intercept is not generally written as y. I mean, assuming that you write your equation of a line in this traditional way, assuming that we write it as y equals mx plus b, general equation of a line as y equals mx plus b. Where, remember, these are the constants. The m is the slope of the line, and the b is the y-intercept of the line. This is going to be b, and this is going to be 4 times m. A couple of you guys are doing the substitution already in the chat box. But statement 1 says that b is equal to 4 times m. So this becomes a substitution. Sorry, that's not supposed to be a p. This becomes a substitution that you can use, right? You can plug in 4m where you saw b in the equation. So if you do that, then the result is y equals mx plus 4m, where we still don't have any idea what m is, right? So substitute. If you do that, you get y equals mx plus 4 times m. Now, what are we interested in? I mean, again, what's weird is that a lot of people kind of forget what the goal is halfway through. What are we doing? Yeah, Anoop, I like that. That's a very good summary of it. What is the x-intercept? In other words, when you hit the x-axis, which means when y is 0, what is the value of x? So Jalajah, that's correct, but make sure that you not only say that y is 0, make sure you say what Anoop says there, which is you are trying to find specifically what x is when y is 0. So what is x when y is 0? That's the question. When y is 0, what is the value of x? And I mean, you may want to write that down up next to the question or whatever notes that you have here, because x-intercept is kind of for me, the phrase x-intercept is not immediately meaningful in terms of algebra. It is in terms of visual. Like, I mean, x-intercept to me is the place where it hits the x-axis. But when y is 0, what is the value of x? I would just go ahead and write that down just to make sure that my bearings are there. So, okay, well, mx plus 4m is 0. You can factor m out of that. So that's m times x plus 4. I mean, if this were a pure algebra entity, then that would mean that either m is 0 or x plus 4 is 0. But we know that m is not 0 because, look at it, it's non-horizontal. So m is 0 means you got a horizontal line. So this is ruled out right here, this thing on the left. That's not a thing. Oh, hey, look at that. Looks like we've got one value of x. We are stuck with it. We are stuck with a single x-intercept. So that's sufficient. Sufficient. Exclamation point, exclamation point, exclamation point. Neat. I mean, notice, one thing to notice here is that you find exactly what you are looking for in the problem, and really not one thing more than that. Like, we found the x-intercept. Notice we still didn't find the slope. We still didn't find the y-intercept. We most definitely did not find where the line is. We don't know any of those things. But we magically know that the x-intercept is at -4. Keep that in mind, because a lot of these problems work like that. Like, they're very good at writing data sufficiency problems where you find exactly what you are looking for, and that's it, because they want to make sure that you are focused on a goal. So you're not going to find everything. If the question says this, then it is a virtual certainty that you are not going to find where the line is. So, okay, if you don't know, if the algebra approach doesn't work for you, it's not a big deal. Just switch to making lists of cases and testing those. So let's look at that. In this case, we would need, our cases would be lines that satisfy statement 1. So basically, you're going to pick a line that satisfies statement 1. And then once you do that, you're going to find the x-intercept of that line. So, and when you do this on your paper, of course, you don't need to write all these words, but I mean, I'm trying to make something that is easily understandable here. I mean, you could certainly abbreviate these columns. So, okay. Someone give me some lines, some specific lines that satisfy statement 1. Like in y equals mx plus b form. Just throw a few cases at me. Chat box. Y equals, sure, 1x plus 4, or like 2x plus 8, or 1x plus, yeah, exactly. Those are pretty good. So let's start with those. Y equals 1x plus 4, y equals 2x plus 8. Y equals x over 4 plus 1. Y. You try some negatives too, like y equals negative 10x minus 40. And, just for kicks, things like, 100,000x plus 400,000. I mean, the point is to try enough cases for you to see a pattern. Because in these problems, when things are sufficient, the pattern is going to jump out of there pretty quickly at you. So let's take a look at these things. If you find the x-intercept, I'll show the work for like one of these things, and then you just set 0. So basically, we're just going to wipe all these y's and put 0 instead, and then solve them. So conveniently, in an online classroom, you can just erase all the y's and put 0 there. Okay, so what we're doing is basically solving 0 for all of these things, because that's what an x-intercept is, right? So if you solve that, you get -4. If you solve the next thing, you get -4 again. And I mean, you're going to get -4 enough times until, I mean, by the time this happens, probably 2 or 3 or 4 times, you should pretty much be convinced, right? So, but the point is, okay, I'm convinced that I'm not going to get anything else. Sufficient. So, I mean, notice again, what's the other thing that you should notice about this process is that your goal is not to prove sufficient. Your goal is to prove not sufficient. In general, that's kind of how it works especially with this approach. Because, I mean, again, think about what is a tangible thing that you can try to get and what is not. I mean, 2 different x-intercepts is totally a thing that we can strive for. Like once I have a -4 here, I have a very concrete goal, which is to see if anything other than -4 ever shows up. Whereas this is not a concrete goal. I mean, stuck with 1 x-intercept is this weird abstraction that I can't try to get stuck with 1. I can try to find 2 and then fail. So just keep this in mind because this is what you are ultimately trying to do here and not this. With an algebra approach, in general, you're trying to do that because you're trying to solve for x, which we did here. But with non-algebra approaches, your goal is to try to make two different things happen. Make sure you are on board with that. Okay, so that's statement 1. Statement 2 we can make much shorter work of here. So let's do statement 2. Notice we're not ever going to have to combine these because statement 1 is already sufficient. But you're going to see it's going to take a second to load up because I basically photocopied the entire board from the last problem. Okay, let's do statement 2. Statement 2, ladies and gentlemen. Okay. So statement 2 in general, let's go ahead and just do that visually in terms of the theory department. Probably easier to visualize this. I mean, you can probably show that it's not sufficient using algebra 2, but this time all we're doing is x-intercepts and y-intercepts. So it's not this awkward comparison from statement 1. So the y-intercept is -3. That means that you have to go through this point that is down here. You have to, there's a point there that you have to go through. Boom. Okay. But I mean, two different x-intercepts, if literally the only thing you know is that you go through that point. So two different x-intercepts is pretty easy to find. I mean, there's one x-intercept, and there's quite different x-intercepts. So I'm done. I found two different x-intercepts. Notice I don't need to actually like find coordinates of these things because it's clear that there's more than one possibility. In fact, I can hit that x-axis absolutely anywhere in the world. So you can, no doubt that this is not sufficient. You can actually have any x-intercept in the whole world. Except for 0. I mean, you can't hit because the line's not vertical either. But, okay. You could also make a list of cases here too. It wouldn't take you very long, right? So pick a line, and then find the x-intercept. Okay, so I mean, anything whose y-intercept is -3, right? So you can do y equals 1x minus 3, and then y equals like 2x minus 3. Okay. Well, the x-intercept of those, you set them equal to 0. If you solve that, that's 3, and this is, whatever it is, definitely not 3. So, not sufficient. Boom. Done. So, overall, this is A. Any questions about that? Janie, I don't see why not, although that will be a lot. The question is, if I use the standard form, ax plus by equals c. You can, I mean, what the best answer I can give you to a question like this is that you should go ahead and try things. I mean, if you think of something to try, just throw it at the problem when when you're practicing and just see if it works. Because I mean, this is a thing. I mean, this is a form in which you can express the equations of lines. But on this problem, it's not. I mean, this is not going to work very well in the problem that we're looking at right now. But the best answer is try it. See what happens. I mean, in statement 1, you're going to realize pretty quickly that this is awfully inconvenient because the problem with ax plus by equals c is that it doesn't, the slope and the y-intercept are not things in that equation. I mean, so it's not going to work very well. Not so great here. because slope and y-intercept are not things in this equation. But, on other problems it'll be fine, right? It all depends. But what you should do, basically put your head up and look around and see what is in the problem. When you see statement 1, it should be, before you even start the work, it should be pretty clear that this form is inappropriate for statement 1. Statement 1 has a y-intercept and a slope in it. It's got nothing to do with this equation. What do you question mark? But if you rearrange them, then you're basically just making it y equals mx plus b. So, yeah. Okay. So, let's see. How much time should we spend on a question like this? That's going to vary from person to person. When it comes to time management, you shouldn't memorize specific amounts of time. By the way, we still haven't gotten to the main point of this question as far as today is concerned. But when it comes to things like this, you don't want to memorize specific time guidelines. In fact, I've done this in previous study hall sessions, but I don't mind doing it again. Here's everything you will ever have to know about time management. Number 1 is always have a purpose or a goal for what you are doing. If you don't know what the goal is, figure it out. If you don't have one, stop, figure it out. And if you honestly can't figure it out, quit and guess. Quit, guess. Okay, if you do have a goal, and you are doing something, if you do have a purpose and you're doing stuff, if you get stuck, quit. Try to think about something else. Try to think of another method. If you can, try it. If you can't, quit and guess. Guess and move on. That's pretty much it. That's all you have to know. The only other thing is don't use the same thought process more than once. If you try something and it doesn't work, don't try it again. That sounds kind of obvious, but a lot of people do that. A lot of people will try algebra on some problem, will get stuck, and then we'll try algebra again. It's kind of strange. Try each approach one time. If it doesn't work, then, try another approach, but don't keep banging your head against the same wall. So the answer to how much time should we spend, if you are stuck after 20 seconds, you should go ahead and guess after 20 seconds. If you are still honestly making progress after a longer time, then by all means, keep working. And if you can be very brutally honest with yourself about when you are stuck, you will not have any issues with time. In fact, you will find that there is plenty of time to do anything on this test, even including failing with multiple approaches and still trying others. In other words, if you have any issues with timing at all, it's because you are sitting there staring at things that are not working. So, there are charts, there are time guidelines, there are stuff like that, but those are only for people who don't yet have enough self-discipline to do this, to just quit when they are stuck. If you have that kind of self-discipline, then all of those timing charts and so forth are not really necessary. So that's worth writing down on the board. If you get stuck, quit. All of the timing charts, specific numbers of minutes, etc., are only necessary if you don't have the self-discipline to do this. If you do, you don't ever have to think about timing charts or numbers of minutes because you will not have issues there if you have the self-discipline. The other question before we look at the main point of this is this question. This is totally irrelevant because you will have no idea what the level of the questions is in the first place. So it's impossible to have, you will literally have no idea what the level of the questions is. So irrelevant. There. I mean, really make sure that you are never, ever, 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 ever even thinking about difficulty levels as you solve problems. Because you will not know them, number one. And more importantly, number two, they are a big distraction from the things that do matter. I mean, if you are even thinking about that at all, then you are solving the problem with less than 100% of your brain power. And I don't think I need to tell you that that's a bad thing. Okay, now let's make sure that we have the main point of this whole deal. So let's come back to this. And again, let me show you what answers you guys picked for this thing. Oh, I already erased them from the board, but remember that you guys picked C was the most popular answer here. Even though the title of today's session is C is a trap today, folks. But nevertheless, let's have a chat about answer choice C. Let's chat about choice C. If you pick choice C, okay, first of all, this is kind of a, loaded language or whatever, but it's way too easy. I mean, if you think about it, the very first thing that you learn on day one of studying lines in algebra class is that it's mx plus b. And if you have both statements together, then you have b from statement 2, and then you just get a number for m in statement 1. So, you're basically just handed m and b with no work. You find much more information than you actually need. Because, I mean, again, the only thing we actually want in this problem is the x-intercept. I mean, we don't care where the line is, and we certainly don't need m and b. And then most importantly, this solution completely ignores the key math concepts in the problem. Actually tested in the problem. Like what key math concept is tested in the question? Where am I going with this? Like, what is the thing that the question is actually asking you about? Chat box. Like, what thing is it asking you for? It's asking you for an x-intercept. Yeah, exactly. And I mean, this is going to sound possibly really stupid in these words, but the question says, what is the x-intercept, which means you had better be thinking about the x-intercept, right? So if you're not thinking about the x-intercept, oh boy, are you in trouble. So if the question asks about an x-intercept, you'd better be thinking, you'd better have to think about the x-intercept. Like if you pick C, you're just saying, oh dude, I have M and I have B, so I know exactly where the line is. And then you don't even need to think about x-intercept. So it's not going to be how these problems work. In general, when you have this kind of thing, This is the infamous C trap. If you encounter this kind of situation, do not pick choice C. Don't do it. It's not going to be right. C trap. I mean, there are lots and lots and lots and lots of these. In the official guide problems, in the last like 60 or 70 of those data sufficiencies, there are like 15 C traps. So, yeah, they love this. They love it, they love it, they love it. So, and I mean, if you think about why they would do this, they're not doing this to be mean. I mean, if you understand what they're testing here, it helps you attack these problems. I mean, because again, what they're testing is not so much how good are you at geometry. They're testing, can you focus on a goal and find it? And I mean, the goal that you're supposed to focus on is what is the x-intercept. So in other words, they engineer these problems specifically so that if you do not have that goal, you will get the problem wrong. And that's what they're trying to do here. So if someone sees this question and says, I need to find mx plus b, you're dead. I mean, they specifically wrote the problem so that that will not work. Because what they are testing above all else is focus. They want to make sure that you can find the thing that you are actually supposed to find. So that's why these problems work the way they do. Because if you find too much information, then you're not really focusing on the problem at hand. So when you see this kind of situation, you can get rid of two choices. One of them is, of course, C. C is the trap answer. Can anybody tell me what other choice you can get rid of when this kind of situation arises? Yeah, not D. You can get rid of E. Because I mean, again, think about what's going on. I mean, these are problems where the two statements together are very obviously sufficient. In fact, they are so obviously sufficient that that's the trap. So if you think about what choice E means that together they are not sufficient, which of course is not true. I mean, if I give you the slope and y-intercept of a line, then you have one line, which would very clearly be sufficient here. I mean, the trap is that you don't need that much information. And it turns out that all you need is statement 1. But I mean, if you pick E, that means that even if you know exactly where the line is, you still can't answer the question, which is, in other words, choice E means that a single line will have 2 y-intercepts. I mean, that's not really a thing. So just remember that you can eliminate these two answers for very, very different reasons. I mean, you can eliminate C because it's a trap. I mean, C is not unreasonable. In fact, the problem with C is that it is very obviously reasonable, and so they're giving it to you as a trap. So you eliminate C because you know that's how they write traps. You are keen to their game here, because you know how they roll. That's not why you're eliminating E. I mean, E is not any type of trap answer. I mean, E is just logically impossible in these situations, because if the two statements together combine to be obviously sufficient, then it's not going to be E. So you eliminate E because it's logically impossible in these situations. Okay. But just keep this in mind. C trap, it's a thing. The better you are doing on this exam, the more likely you are to encounter it, but all of you will probably run into it at some point. Okay, let's look at another problem. How about this one? Okay. Here's a timer. Don't forget where the multiple choice answers are found. That would be here. All right, so remember, a lot of you guys still don't have answers to this thing. So go ahead and pick something. Remember how this test works. This is a test where you have to pick a thing, regardless of if you have any clue what's going on at all. The GMAT itself does not allow you to move on until you actually respond to the question. So please pick a thing. All right. So here are your class responses. There are still a bunch of non-responders here. Again, if you are one of the non-responders, there's only so much I can do, but you can't be a non-responder. There's no such thing on test day. So here's what you guys picked. What's interesting here is that there are at least 5 people whom I am just not getting my message across to adequately well. Those are this one person here and these 4 people here. Because, I mean, the whole theme of today is problems on which C and E are not right. So I remember this whole thing that we just did right here. This whole, that's not it. This whole shtick right here. I mean, this is the theme of today. Problems where C is a trap and where E is logically impossible. So, I mean, just if you're picking C or E here, check yourself. I mean, maybe it's my lack of communication, but I mean, check whether you're getting the lessons that you want to get from today. So, yeah, it's not going to be C or E. Let's go ahead and talk about it. So let's shrink this. The difference between Mary's and Jim's annual salaries was twice the difference between Mary's and Kate's, and Mary's is the highest. I mean, one way to do this is to picture it on a number line. I mean, Mary's is going to be the last thing on the right, if we do it that way. So let's picture that on a number line. Number line. Mary's salary is going to be somewhere over here on the right, because hers is the highest. And then whose is the lowest? We got one person saying we do know. We have one person saying Jim, one saying Kate, one saying we don't know. What's interesting is that this means you're not thinking enough about this problem before you jump into it. I mean, in general, you should never rush the reading of the prompt part of the problem. I mean, you should take as much time as you need to understand what's going on in the prompt. I mean, even if it's a long time, it's worth it. Like you cannot come out of that prompt thinking that Jim's salary is the lowest, or you're thinking that Kate's salary is the lowest, because it's not. The lowest salary is Jim's. So, and don't leave the prompt and start investigating the statements until you figure that out. I mean, you've got the difference, because Mary's is the highest, so the differences are both things that are lower than Mary. And the difference between her salary and Jim's is bigger, which means that Jim's salary is even lower than Kate's. So Jim's salary is over here, and Kate's salary is in the middle. Again, if it takes you a minute and a half to figure that out, then that is a minute and a half totally well spent. I mean, do not ever rush that part of the process, because that's where all of the understanding comes from that you need. So Kate's in the middle, and moreover, what we can figure out is that Kate's salary is in fact exactly in the middle. Because if this difference is twice as much as that is. So if you think about what that means, like this is going to be some difference d, and this is going to be twice as much as d. So this is going to be the exact midpoint. I don't want to put another dot there. However long it takes you to figure that out, you should take that long. I mean, do not ever rush that part of the problem, because if you do, then you're not going to get what you need to get out of it. So Kate's salary is exactly in the middle of the two. Okay. How about that? Well, so now let's make sure we know what the goal is. The goal here is, okay, what is not the goal? I mean, make sure that you guys know what I'm doing here. The goal is specifically not to try to find what? The goal is to find the mean. The goal is not to find the individual salaries. That is where I'm going with that. So Alex, yeah. I mean, do not try to find the individual salaries. If you try to find those, then you will fall into the trap that they are setting for you. I mean, you need to have focus here. If there are two or more possible values for the average, then not sufficient. If there is only one possible value for the average, then that's sufficient. And I mean, once you kind of know how these guys roll, it's going to become pretty predictable. I mean, you should expect that the individual salaries will still be unknown, even if you establish the mean. Because that's how these problems work. I mean, these problems have a focus. Like in the last problem we did, it just said what is the x-intercept. So you should expect to find the x-intercept without finding the line. Here the question says what is the mean, so you should expect to have the mean, but not the individual salaries. I mean, if you're scoring really low on the quant section, then that's not a thing. But in general, otherwise, it's going to be a thing, because they're going to make sure that you have a focus here. Okay. Well, Kate's salary is exactly the middle, which means that Kate's salary is the mean. There it is. So I mean, notice, even if it takes you a very long time to figure that out, it's fine, because as soon as you figure that out, this problem is, you're basically done. I mean, you've basically got what you need to solve this thing. So Kate's salary is the mean. Kate's salary is the mean. There it is. I mean, you can also, if you don't want to do this visually, you can also do it algebraically. I mean, there are a bunch of ways that you can do that, but algebraically, you can let Mary's salary be, M, and then Kate's salary is Mary's salary minus this difference, and then Jim's salary is Mary's salary minus twice that difference. And so then if you add all of those up, then the mean is the sum divided by how many. So it's going to be all of that divided by 3. If you add that up, you get 3m minus 3d. So that's m minus d, which is the same thing as Kate. So you can also do it algebraically. Like, you don't have to do this number line thing that I did. I mean, there's a lot of ways to approach this. But regardless of how you do this, you do need to play with these words in the prompt and figure out what the heck is going on in the problem before you start going crazy with it. So once you realize that, then the solution is pretty quick to get. Because, I mean, Jim's salary doesn't tell you. Because we don't know the separation, right? We don't know how far apart these are. We just know that Kate's happens to be right in the middle. So statement 1, the mean could still be anything higher than 30,000. So that's not sufficient. But statement 2, the mean is Kate's salary, which is 40,000. Sufficient. Notice that you still have absolutely no idea what the other two salaries are. Because that's not the focus of the problem. You don't really care. But now, again, choice C in this problem is the trap. Let me upload that graphic again. C, trap, land. Shrink it a little bit so that we can. The problem, if you pick C here, again, these are, C is way too easy. It's way too easy, right? You would have 2 salaries, and then you could just subtract them to find the third salary. You find much more information than you actually want. Sure you do, right? You find all of the salaries, and we don't care about finding all the salaries. And then lastly, and most importantly, it totally ignores the idea of an arithmetic mean. If you pick C here, you're just saying that we have all of the salaries. So that thought process has nothing to do with average, with arithmetic mean. So, yeah. Alex, no, because you have to. Otherwise, it would be not sufficient. Because if you ignore that fact, then Kate or Jim or both might make more money than Mary. So here, let me take that to another page and show you what I'm talking about. Here. Let's go ahead and investigate that. So Alex says, seems like the fact that Mary's salary is highest can be ignored. So I like what Alex is doing here. When you review the problems, it's actually good to think about what happens if you tweak them in these kinds of ways. So it's a good idea to think about what happens when you tweak data sufficiency problems in particular. Because most data sufficiency problems are very purposefully crafted. Like they work in very specific ways that, like for example, the fact that this is twice is a really big deal. If this was like 3 times, then you would need choice C to be the answer. But the fact that it's exactly twice is what makes this the mean. And so if you change that at all, then the problem is totally different. So if you see, here's the problem. If you ignore the fact that Mary's salary is highest, then you have multiple possibilities. Like if you don't know that Mary has the highest salary, then you have to consider the cases where the other people's salaries are higher than hers. So if you have that, if you take this fact away, you need to consider different cases. So like you have 4 cases, right? You have, let's just put 4 number lines. Paste, paste, paste. There's 4 different possibilities in this case, right? Because then you don't know either Jim or Kate or both might make more money than Mary. So you need to consider all of those. So here's Mary. Let's just say M. And then just for the ease of reference, let's go ahead and color code. So Kate might be here like she is in the original. She might be over there to the left of Mary. But she might also be to the right of Mary, because now we don't know. And then lastly, there's Jim, who in the original problem, Jim also has a lower salary than Mary does. But if we make this change, then we no longer know that. So you could have any of these things happening. Let's move that over there. You could have that, you could have that, you could have that, or you could have that. So if you actually take that condition away, then you wind up with E, like elephant. Because if this is, I mean, like imagine that, I mean, if you have 30,000 and 40,000, then you're looking at either this case or this case. But if this is 30,000 and that's 40,000, then Mary's salary could be absolutely either of these two, right? If this is 40K, then Mary's salary is going to be 50K. But if this is 40K, then Mary's salary is actually going to be like 36,666.66666. So yeah, if you take that fact away, then you get E. How about that? So I mean, it's cool you're thinking about things like that, because that's going to expand your horizon data efficiency. I mean, the disadvantage, obviously, is the fact that you have no answer key to a tweaked problem. So if you don't, assess accurately what's going on, then there's no one calling you out on it. But it's still good to think about this kind of stuff. So, yeah. Harpreet's, yeah, that's the reason why, right? The difference could be either of those two things. We don't know. So, but yeah, I mean, investigate, right? Play around with data sufficiency problems and just see what the deal is. By the way, just to make, I mean, we're not talking about sentence correction today, but make sure you don't tweak sentence correction problems. I mean, just throwing that out there right now. Do not take the sentences written by GMAC and try to edit them. That is a very, very bad idea. But with data sufficiency, you can play around with stuff and see what happens. Okay, let's see if we have time to do one more of these things. Let's see. I don't know. How about not that? Okay, here's this one I'll give you a little bit less time for because there's not as many words in it. So there you go. Remember where the multiple choice answers are located. They are located there. All right, good times. Okay, let's go ahead and pick something. If you have to guess on this, then, please remember what the theme of today's thing actually is. Okay, if you are not picking an answer, please pick an answer. I'm looking at you if you are Abby or Brajendra or Denalia or Jennifer or Layla GMAT or Nicolin or Parv or Raphael. You got to pick something on this test. Okay, I mean, again, here are your responses to the thing. I mean, there's still 7 non-responders. One of them is me. But if you are one of those 7 people who did not pick a response, there's only so much finger wagging and scolding that I can do over the internet. But you can't not pick an answer. This is not a thing. So. And I mean, also, if you are one of these 3 people, please remember what the point of today's session is. I mean, it's problems where the answer C is a trap and where E is impossible. So we'll see that again, but let's take a look. So again, remember that you basically have two families of approaches to these things. One family of approaches that you have is to use theory or whatnot. And the other family of approaches is making lists of cases and testing them. So here's the problem again. Let's import that graphic from over there. Okay. So yeah, here are two different families of approaches. And then we're not talking about statement 2 anymore, so let me get rid of that. Well, all data sufficiency. Just think about it like this. I mean, if you don't succeed with textbook style solutions, then, that's not the end of the world. Just try listing cases. Just try testing stuff. So, because this is, again, you should never have indecision going on with data sufficiency. I mean, you should always be trying one or the other of these two things. So, like with statement 2, it should be pretty clear that statement 2 is not sufficient. So, I mean, you're clearly not going to have the same remainder when you divide any number by 5. But you know what? Before we do this, before we even go through how to do the problem, let's say that you had 10 seconds to answer this thing. Can you answer it? So you literally had 10 seconds. Well, what can we identify? Because I mean, okay, after today's topic, you should recognize that these are things. I mean, today, that's the topic of the day. But there's two things that you can notice right away here. The first thing is that statement 2 is not sufficient. I mean, that should be clear if you know what that means. I mean, okay, basically I'm going to be sort of blunt here, but if it took you more than about 4 seconds to realize that statement 2 is insufficient, then that means that you do not have a good enough grounding in what sufficient and not sufficient mean, and you need to fix that. That's a problem, and you need to fix it. Because, okay, sufficient here means that you get one remainder all the time. Not sufficient means 2 or more possible remainders. Sufficient means only one possible remainder. I mean, statement 2 means you are dividing absolutely any number in the world by 5. So there's going to be a lot of different remainders possible when you do that. So that should be a quick and easy realization. The other thing that you can realize is what Anoop is saying, and what is basically the theme of today, which is this, right? This whole idea of a seed trap again. So if the combined solution is way too easy and gives you too much information and completely ignores the concept. I mean, all three of these are true, right? It's way too easy. I mean, you have K and then you can plug K in and find N. It's not how it's going to work. It gives you too much information. I mean, we don't want the specific values of K and N. We just want the remainder. And most importantly, if you pick C here, you're saying that you don't even need to think about remainders. I mean, you're saying that you're just going to find K and N and then smile. That's not how these problems work. I mean, again, when I put it in these words, it should sound really obvious to you. But in a problem about remainders, guess what you're going to have to think about? You're going to have to think about the remainder. Hey, I mean, because that's what the problem is about. So, but if you put these realizations together, well, this statement 2 is not sufficient, so B and D are gone. And then with this realization, C and E are gone. Oh, hey, I guess it's A. Even if you have no clue how statement 1 works. even if you do not have clue number 1, how statement 1 works, you can answer this question. That's pretty cool. I mean, it happens a lot. You would be surprised how often this is a thing. Not always. Sometimes you still have to solve but you could do that on the x-intercept question as well, right? Like if we go back to this one real quick. Statement 2 is definitely not sufficient here because it's just a y-intercept will not tell you an x-intercept. So if you realize that this problem is also a trap, then you can solve it in like 15 seconds. You can be like, okay, it's not C or E, and it's not B or D. So, oh, it's A. How about that? Even if you have no idea at all how statement 1 works. It's pretty cool. We like that. Okay, so let's look at this and see how it actually works. But again, recognize these kinds of traps. They are very common. They do this a lot. So if you wanted to do algebra, you certainly can. Let me typing that kind of algebra in this online classroom is annoying, so let me do it in equation editor and import it. So if you if you want to do algebra, you can just multiply that out. Which is annoying, but that's all it is annoying. Like it's definitely not going to take you way too long. It's irritating. I don't like having to do it because I'm lazy, but it's not that hard, right? So you solve it, then it first multiply out the first couple terms. That's and k squared plus 2k plus 1 times k plus 1. Okay, so that's this. And then you could multiply this all out, or you could just notice what's going to happen here. Like you have to multiply, I don't want to do that. You have to multiply all of this stuff by all this other stuff, right? So you have to multiply k squared by both of these things. You also have to multiply 2k by both of these things. And you also have to multiply 1 by both of these things. I mean, you could do that, or if you have a goal in mind, you don't have to do that. Because remember, the goal is to find the remainder when you divide by k, which means that things that are multiples of k just don't matter at all. So, and every single thing that we're multiplying together here is going to be something times k, except for 1 times 1. Like that is the only thing here that is not going to have a k in it. So again, if you have a goal in mind, you can speed up this process by saying, you know what, dude, if there's a k, I don't even care. So this is a bunch of stuff, a bunch of multiples of k plus 1. So when you divide this by k, you're going to get a remainder of 1. Okay, that's cool. I mean, if that doesn't fly, then like if you don't get this algebra off the ground, then it's not the end of the world. You can just make a list of specific cases and test them. Unique, if I gave you statistics on that, they would be useless for everybody. I mean, how is that going to help you during a test? It's not going to. I mean, just look for it. I mean, if you see a problem where, I mean, my goal after today is for it to be pretty obvious when this is a thing. Like if you look at C and you're like, oh, I just plug this in and plug that in and I'm done, then you should be hyper aware of this as a thing. I mean, I can't give you any statistics on it. I can give you OG statistics. Like in the last 70 problems of the OG, there's 15 of these. So I mean, that's more than a 20% hit rate. So you're definitely talking about something that happens a lot. I mean, I'm sure you'll see 1 or 2 of these at least on your test, if not more. But just look for it. Just keep an eye out. You can make a list of cases and test them. So in that case, we would pick k. and then find n. And then what's the remainder of k divided by, or n divided by k? So k has to be more than 1. So if k is 2, then n is 3 cubed, which is 27. The remainder when you divide that is 1. If k is 3, then n is 4 cubed, which is 64. Remainder of 64 divided by 3 is 1. If k is 4, then 5 cubed is 125. The remainder of that divided by 4 is still 1. Sticking with numbers that are relatively nice here. Like if k is 9, then that's 10 cubed. So that's 1,000. 9 goes into 999. So I mean, I'm pretty convinced by this point. So again, just make sure that you know there are 2 families of approaches to data sufficiency. If you got that, then you're going to go a long way. All right, so that's all the time we've got for today. We have a few more of these in the reservoir here, a few more of these C-trap type of problems. So one of the future sessions is definitely going to involve this kind of stuff. Maybe the next session, maybe not. We'll see what the deal is there. The next session is in either 2 or 3 weeks. I don't know off the top of my head. The schedule is a little bit interesting this next month or 2 because there's some holidays and there's some other stuff that's in the way. But we will. The rest of this stuff is definitely going to be. There's going to be some more C-traps in an upcoming lesson. Yeah, it has to be, Angelina, it's got to be an integer. Make sure you follow the directions. By the way, also, make sure you know that they are not going to pull weird stuff like that on you. Like, whenever a problem deals with divisibility or remainders, it's always going to be whole numbers only. I mean, you should still check the problem statement, but they're not going to suddenly whip out a divisibility problem that has to do with fractions, because that's not even a thing. I mean, divisibility is not even defined. There are fractions. You allow fractions and everything is divisible by everything. Is 7 divisible by 5/3? Sure, it's 21/5. I mean, So this is only a concept that's this concept only exists for integers, this whole divisibility thing. Okay, let's kill it. And actually, you know what? Weirdly enough, even if you define a remainder for dividing by a fraction, statement 1 would still be sufficient, even if you allowed fractions. Like again, tweak it, see what happens, right? I mean, this algebra still works. I mean, even if k is pi or 5/2, this is still a thing. And you're still going to wind up with 1 more than some multiple. But more importantly, yeah, like you said there, exactly. Don't rush. Take your time. Read the themes. See what they say. Awesome. All right. I am going to start logging you guys out here in just a sec. Thanks for attending. And good night and good luck. If you have any quick admin questions, feel free. If not, you guys know the drill. You can just quit out of the room. You don't have to log out or anything like that. I don't even think you can log out. I think you just have to quit. And if not, I'm going to go ahead and log you guys out presently. Thanks, and I will see you in a couple of weeks. Good night, and good luck.